Hi, Thomas.
Hello.
How are you doing today?
I'm good. How are you?
Okay.
Let me post. I'll just chat you the.
Okay.
I have a quiz on Tuesday, so I thought
Okay.
I'd get a session and
You're
review one
the,
later.
actually, you are the first person that has signed up for one of my 30-minute online sessions. I just introduced
Oh yeah.
it. Yeah, I just introduced it about a week ago. I'd had some students that asked for it, and it actually seemed to be working pretty well, so I decided to make it an option.
Yeah. Well, I just thought. I mean, I was looking at your thing and I just noticed that it wasn't that busy on Sundays, so I thought if I needed a little extra time, maybe we could go over. But
Yeah, certainly.
all right. So that's basically what I need to know for the quiz, and we've been doing a lot of matrices lately.
Okay. Let's talk about solving systems of equations algebraically and graphically.
Okay.
Yeah, let me not write it like that. How would you solve that?
Okay, so I'm not great on these, but I think you solve one of them for like one of the variables, and then you plug it in or something.
Well, if you were using solving by substitution, yes. That's
Okay.
the way you would do it. But there's actually an easier way. When it comes in this format, where the x and y are on the left side of the equation and the number is on the right, it's much easier to use elimination to solve it.
Okay.
Okay? And elimination means eliminating one of the variables. Well, I could have made this a little easier. Since you're not real good at these, let's make the problem like that.
Okay.
Okay? Now, eliminating one of the variables is easy because all we have to do is add the two equations.
Yeah.
You can always add or subtract equations. In other words, a plus b equals c plus d, and x plus y equals r plus z. You can add those two, so you have the four terms on the left equal the four terms on the right. Well, the advantage of adding these two equations is that one of the variables disappears, and you end up with 5x equals 24. So you can solve for x. And then once you solve for x, you stick it into one of the equations and solve for y. The secret to algebra is that when you have one equation and one variable, you can solve it. When you have two variables, you must have two equations. And if you have three variables, you must have three equations.
Okay.
Okay? So that's how you solve simultaneous equations.
But which
Now,
one do you plug it back into?
either one.
Okay, just one of them though?
Yes, the simplest one. Both of them have to work when you plug it back in. In other words,
Okay.
these are true statements. So whatever x value is, y has to be whatever it's going to be to make that a true statement. So you can use either equation. I usually pick the simpler one, the one with the smaller numbers.
Okay.
Let's go back for a moment and change that back to 3. Now, not so easy to eliminate a variable. However, if I want to call this equation 1 and this equation 2, if I multiplied the top equation by 4 and the bottom equation by 3, I would end up with minus 12y here and plus 12y there. So
Okay, yeah.
let's rewrite this one. We're going to multiply it by 4. And you see why 4, because 12 is the common denominator between 3 and 4. And I'm working with the y's. I could have worked with the x's just as easily with smaller numbers, but there's going to be an advantage to the y's, and I'll show you in a moment. So the first equation becomes 8x minus 12y equals 56. And the second equation, when I multiply it by 3, remember, you have to do the same thing to both sides of the equations.
Yep.
I get 9x plus 12y equals 30. So now I've got two equations that are identical to my first two, only I multiplied both sides by a number. But now I'm in a position where I can add these two equations, eliminate the y, get 17x equals 86, x equal 86 over 17. And then to solve for y, I would probably go back into the simplest equation, that one. Let's just go through that step. Since x equals 86 over 17, then I would have 2 times x, 86 over 17, minus 3y equals 14. In other words, I can use the simplest form of the original equation. I don't have to use the equation that I multiplied by 4 or that I multiplied by 3. You see that? Okay.
Yeah.
And then now I have one equation, one unknown. I can solve for y.
Okay, that's
Now,
definitely a lot more complicated.
well, yes and no. I pulled these numbers out of thin air. I wasn't working off of a problem. If they give you a problem on a test, these numbers most likely will be integers, and it'll be a lot easier to come up with the solution.
Okay.
Okay? But the process is exactly the same. You solve for x, whatever it is, and then you plug x into either. You actually have 4 equations you could plug x into. You have this one. You have this one. You could use this one, although the numbers are bigger, and it's going to make the mathematics or the arithmetic harder. So that's why I always choose the simplest one, and in this case the simplest one was 2x minus 3y equals 14.
Okay.
Okay, so now let's take one last look at this, because even though I understand matrices is your main concern, the concept of solving simultaneous equations is a huge one. We don't want to gloss over it. Let's go back to the original problem and the way you suggested solving it in the first place, which is by substitution. In other words, when you use substitution, one of the equations is usually solved for one variable. In other words, if I were to solve this for x, I would get x equals 3y plus 14 divided by 2. Right?
Yeah.
Okay. So if instead of 2x, in other words, let's say the problem was presented like this and not the way I originally presented it. In other words, if I gave you 2 equations and 2 unknowns and I said solve that, well, now one of the equations is in terms of one of the variables completely. And so it makes it far more ideal to solve by substitution.
Mm-hmm.
what I'm going to do is go back and plug that in to the first equation wherever I see x. Okay, so the first equation becomes this. That's magic because now I have one equation and one unknown. And you may think that these are hard to solve, but once you master solving these, they're quite easy. You distribute, you get rid of the denominator, you gather like terms, try to isolate y. So I'm going to presume you are an expert at solving single variable equations.
Yeah.
Okay, so it all depends which method you use. Elimination or substitution, those are really the two primary methods that are taught in Algebra 2 as to how to solve two equations in two variables. Now, let's talk about matrices. One of the primary reasons that we invented matrices was for solving multivariable systems of equations. It's easy to solve two equations and two unknowns. We just went through two different methods. And incidentally, the graphical method, both of these equations are linear, meaning they graph as straight lines. Okay, this one, if we were to put both of them in y equals mx plus b format, we would see that I have this for the first equation. The second equation would be y equals x minus 14 over 3. So there's my two functions. Two equations, two unknowns. One way to solve them is to graph them. Well, this first equation has a y-intercept of 2.5. You see that, 10 over 4?
Mm-hmm.
And a slope of minus 3. So if I go to 2.5, slope of minus 3, I get a line like that. That's the first equation graphed. Second equation has a slope of about minus 4.5 and a slope of plus a third. So let's go down to minus 4.5. A slope of plus a third would be very flat, like that. There's your solution for these two equations, wherever they cross. In other words, if you were to go into your calculator and put in y sub 1 is equal to that, and put in y sub 2 is equal to that, it will look something like this. And then you can go and check the intersection to find the solution. Whatever the coordinates on this are is the solution.
Okay.
Okay. What did I took my solution out, but I don't remember what it was. But in other words, whatever x and y coordinates this has, that is the solution for those two equations.
Okay.
Okay?
I think we're allowed to do that on our calculator as well, I remember.
Yes, and your calculator has an intersection function. So just put in your two functions as, y sub 1 and y sub 2, go to the intersection, it'll give you the solution. So now you have three methods of solving two equations and two unknowns. You have elimination, you have substitution, and you have graphical.
Okay. Sweet.
There is no limit as to how many methods they want you to learn. Another method is using matrices. You write a system of equations. Again, I don't know what my other one was. I think it was something like this. Tell me what methods you've learned using matrices to solve a system of equations with some unknown number of variables. Well, first of all, let me tell you, the beauty of matrices, if I add a third variable here and a third equation, the process that we've been using gets more and more difficult. I don't know if you know how to solve 3 variables and 3 equations, but it basically is a whittle down process. You solve 2, eliminating 1 variable, you pick another 2, eliminating the same variable, you end up with 2 more equations but only 2 variables. You use the techniques we've been talking about to solve those, and eventually you get solutions for all 3 variables. Okay? Have you ever done that manually?
I'm not sure if we've done it that way. Maybe we have. We've done it the way where you put it into the square.
Okay.
Like,
putting it into
the brackets, square, I guess you could say.
You're talking about the matrices.
Yeah.
Okay.
And then you like take the column, the row 1, column 1.
So you've used augmented matrices.
Yeah.
Okay. In other words, if I tried to solve this system of 3 equations and 3 unknowns in the normal way, it would take a long time. It would involve 5 steps. No, 6 or 7 steps to solve it. So matrices were essentially developed to solve these quicker. And matrices are the ideal things to solve 11 equations and 11 unknowns. Or when you're trying to predict the weather, you might have 50 equations and 50 unknowns. So regular algebra doesn't handle those situations very well, but matrix algebra handles them particularly well. If I put this in an augmented matrix, I presume what you're talking about is this.
Yeah, that looks familiar.
This is called an augmented matrix, where I only use the coefficients. I don't list the variables. The first column is the x coefficients, the second column is the y, the third column is the z, and the fourth column is the number. Okay? If we can manipulate this matrix and get it to look like this, then x is equal to plus 4, y is equal to 3, and z is equal to minus 2. Okay? This is called a reduced row echelon matrix, where you take a regular matrix based on the coefficients of the variables, and you basically manipulate it with a ton of rules that there's no way we're going to be able to cover in the next 8 minutes, such that you turn it into a matrix where you have 1, 1, 1, everywhere else is zeros, this is your solution. For x, that's your solution. For y, that's your solution for z. And the rules we are allowed to use to turn this matrix into this matrix are very similar for the rules we're allowed to use when doing elimination. In other words, we're allowed to multiply any row by a constant, left side and right side. We're allowed to switch the order of these rows, not columns, rows. We're allowed to do anything we can do when we're manipulating equations. In other words, let's just start. In other words, this is what we're trying. Go ahead.
When we come out with an answer with these, she always had the, maybe we had 2 boxes or something, because it'd always be a third box, or maybe just a second box, and then she would just write little dashes where numbers should go, and then it would be like 1, 1 under the first dash, and that would be row 1, column 1.
Okay.
And you add them together. Or
sounds like, yes, exactly. In other words, how do we take this matrix and turn it into this matrix? Well, right. If I were to look at this matrix, the very first thing I would do is multiply the first row by 1/2. You see why?
By 1/2.
Yeah. In other words, if I'm always allowed to do that, because it's just like equations, I can multiply each row by a constant. So if I multiply the first row by 1/2, I get my 1. That's the key.
Why 1/2?
Because I'm trying to get 1 right there. In other words, I'm trying to turn this matrix into this matrix.
Okay.
Okay? And there's actually 2 steps. You have 2 different things. You have a row echelon matrix, and you have a reduced row echelon matrix. Let's talk about row echelon matrix first. Okay? But first of all, let's finish this step. I'm going to multiply the first row by 1/2, okay? So that gives me minus 3/2 there, gives me minus 1, gives me plus 3/2 there, and gives me 5 there. Okay? If I can turn this matrix into even this, I'm halfway to solving this problem. This over here, where I just put the check mark, is called a row echelon matrix. The only thing that's important in the row echelon matrix is you have 1s on your diameter, and you have zeros to the left and below. You don't care that these have numbers in them. This gives you one solution. It tells you that z is equal to 4 because of that bottom row.
Okay.
Once you determine that z is equal to 4, it makes solving the rest of the matrix a piece of cake. I can go back to my second row and now say, well, 1 times y plus 2 times z is equal to 3. So I can then solve for y, and then substituting in for x, the x row, you can solve for x. So there's 2 steps here that are extremely valuable. One is solving for a row echelon matrix, like this. And since you're probably going to end up doing this in your calculator, the ideal thing to solve for, although this is not a simple thing to solve for in your calculator, I'll tell you that right now. Of all the processes that you can do in your calculator, this might be the most complicated of them.
Yeah, we learned how to do it. I mean, it was It just is a couple steps.
If you forget, go to YouTube, say solve augmented matrices on a TI-84, and it'll show you a 5-minute video that shows you exactly how to do it.
Okay.
But in terms of the concept of the math, this up here is just half a step. That is a row echelon matrix that tells me the value of the third variable, z. The final thing is called a reduced row echelon matrix, is your complete solution. This tells me what x is, what y is, and what z is. If you're doing these manually, it's much, much easier to get to that step there, the row echelon matrix. It's pretty easy to figure out how to manipulate these three equations so that you get a 1, 1, 1 on the diagonal, and you get zeros to the left and below each of your ones. It's a lot more work to produce this, the reduced row echelon. So if I'm doing this thing manually, I'm going to go for the row echelon. Once I get an answer for z, the other two is going to be a piece of cake.
Okay.
Okay? It takes another 15 minutes to figure out how to get it to the reduced row to give you your total solution. So it's far quicker to get the row echelon, and then once you solve for z, take another 5 minutes solving for x and y, which you know how to do then.
Yeah, so then you just do it algebraically.
Yeah, exactly. And you can start with these two equations. In other words, this second row tells me that 1 times y plus 2 times z is equal to 3. So once I know z, I can come up with y pretty easily. And then the first row tells you that 1 times x minus 3 halves times y plus 1 half z is equal to 5. Well, once I know y and z, I can figure out x algebraically. So it really comes down to whether you're using a calculator or not. If you're using a calculator, you're always going to go for the reduced row echelon, because you just have to figure out how to input this original augmented matrix into the calculator. And you can't do it in one step. You actually have to input two different matrices, the 3 by 3 and the 3 by 1, and then merge them together, and then request a reduced row echelon answer for that matrix. And it'll give you this, and that's your final answer. It tells you what all your variables are. And the beauty of matrices is that, like I said, I could give you 11 equations and 11 unknowns, and if you can figure out how to put it into your calculator, you'll have that solution in about 30 seconds. Whereas if I had to do it manually, it might take me an hour and a half.
Okay.
Okay?
Yeah, I get what you're saying.
Okay. Let me just, before I leave you, just address a couple of, I suspect you're going to have to know how to manually manipulate these matrices, right? Or not?
Probably.
Well,
What do you mean?
let's go one more step. In other words, my first step, merely reduce the first row to 1, number 5. Okay, my second row is still this. I'm allowed to add equations to one another, or subtract equations from one another, or switch around the order of these things. So let's just pretend, because we don't have much time, that that field was 0 to start with. So I'm going to change it to 0 here. Okay? Mm-hmm. Now, my next step is, I'm sorry, let me change that, make that a -3. I pulled this thing out of thin air, so I didn't give much thought to constructing it and how we're going to solve it. So you see how this matrix is the same as this matrix on the left?
Yeah.
Well, what can I do to get a 1 in the right spot right here where that 4 is? I could add these two matrices together. In other words, my first goal is to turn this into a row echelon matrix, not a reduced row echelon. I just want to make sure that I got a 1 there, a 1 there, a 1 there, and zeros to the left. Okay? If I can get this matrix, whoops, sorry, I put one too many zero there. In other words, I'm trying to turn it into that for starters. Well, notice that I can add the second and third rows together. What will that give me? Well, first row stays the same. If I add rows 2 and 3 together and replace row 2, which I'm allowed to do, I get 8, 1, 1, 35. Now I got that and that. I keep whittling this thing down, figuring out creative ways of adding, subtracting these rows, switching them around, until I produce 1, 1, 1, 0, 0, 0.
Yep.
I do not care what is in these three spots right here. As long as I get it 1, 1, 1, zeros to the left and beneath, I have a solution for Z.
Okay.
Okay? And that's the essence of augmented matrices. We didn't really have enough time to go through one. These are incredibly long problems, especially when you deal with 3 by 3 matrices. To do one of these manually would probably take an hour, especially if we were trying to convert it to a complete reduced row echelon matrix, because we could just keep manipulating these rows until we produce that, but it's kind of hard to do that. I mean, it takes a lot of creative thinking and stuff like that. Right. So at some point you're going to get to the point where they're going to want you to know how to manually manipulate these rows and add them to one another and switch them around, but in the end you're going to use your calculator to solve it.
Okay.
Okay. All right. Well, hopefully that was enough to help you a little bit. This was a tough subject to tackle in a half an hour.
Yeah, and tomorrow I'm sure we're gonna have a little review session, and I can go talk to her about it too.
Okay.
So, but I definitely understand them a lot more, and same with the solving systems of equations.
Yeah. Okay.
All right. Well, thank you.
Good luck to you. Have a happy Thanksgiving, and I'll talk to you after Thanksgiving, probably.
All right. Yeah, thanks. You too.
All right, Thomas. Bye-bye.